Rock and dust samples brought back from the near-Earth asteroid Bennu contain organic matter, including amino acids and all 5 DNA and RNA bases, as well as salts that formed early in the history of Bennu's parent body, according to a pair of studies by international and Australian researchers. NASA Goddard's Jason Dworkin is beaming in once again to take us on a deep dive on this episode of Talkin' Science. Jason, welcome back to Talkin' Science. This is a pretty exciting find.
Great to be here. I'm delighted to share it with you and your audience.
It is good to have you back. We've spoken at each key milestone in this journey of discovery about the sample returned by OSIRIS-REx, and highlighting that while it was an American effort to bring Earth the sample, its research is open to the world. Some Aussies have dug deeper and found salt. What does that tell us?
So that's one of the most amazing discoveries that we've had is the salts which have been discovered by our colleagues among other places, Curtin University, as well as in the States. This shows that the parent asteroid that Bennu came from dried out from a mud from a very wet object, leaving these salts behind. Very trivial sounding salts, sodium chloride like table salt, essentially baking soda, and sodium fluoride like the stuff in toothpaste. These are all things which only happen when briny water dries down a lot. And this is left over. And the exciting part is that these would not have been possible without a sample coming back. So, for example, the wonderful Murchison meteorite that landed in Murchison, Australia in 1969 is one of the pinnacles, one of the milestones to look at for meteorite organics, but it landed on the ground. And so if you found these salts in it, you wouldn't trust it. It also landed in air. And these salts are things that immediately pick up water from the atmosphere and disappear. So it is crucial to bring them back and keep them in a controlled environment to make these discoveries. And we found that this result, as well as the organic results that I'm working on, found that Bennu's parent object, some 4.5 billion years ago, formed in the outer solar system, past the orbit of Jupiter or Saturn, in an icy environment, rich with ammonia, the ammonia ices that then melted and formed a clement environment, about room temperature, a brine, moderate pH 8 or so. So almost ideal conditions of what various people think are for the origin of life. Mild environment, a pretty long time, organic rich, salty, but life never formed on Bennu. Why? What did Earth have that Bennu didn't? These are our key discoveries that will be coming in the future, I hope.
That's a pretty existential question, isn't it? Why us? Why not anywhere else in the solar system? There's no better reason for this science. And in answer to many people who say, what's the point of exploring space? What's the point? This is the point. Why are we so special here on Earth? And why should we be taking care of this planet? It's kind of the extended part of this research.
Indeed. So it helps us understand our place in the solar system, place in the universe. Furthermore, these organic compounds and these salts were delivered to the early Earth. That means they were also delivered to the early Mars and Europa and Enceladus, Ceres, what have you. So understanding what to look for that comes in just by natural astrophysics is important when we eventually go to send people to Mars, or when we hopefully bring back samples from Mars in the next decade. We'll be able to understand what materials would have been naturally present from the astrochemistry of the formation of the solar system from objects like Bennu, as opposed to being from life. And so if you see the source of amino acids that we see in Bennu on Mars, you shouldn't necessarily get excited that you've discovered life or that you need to protect that area from Martian biota. Or protect yourself from Martian biota, depending on what your goals are in Mars colonization. So these are all important steps for expanding humanity, not just mentally, not just imparting wisdom on where we come from, where we're going, but also even practically.
Yeah, exactly. And at this point, we need to become a multi-planetary species. I think it's the next evolutionary step.
Right, and even maybe closer in the next at the end of the next century, in the 2180s, 2190s, 2170s. It's hard to say. Bennu could actually impact the Earth. We won't know until 2135 when Bennu makes a close approach. Then we'll understand that better. But the data that this mission has produced has allowed us to refine that impact probability. And it's still very, very low, but it's among the most potentially hazardous objects that we know about. But we have all this information now. We know details about the asteroid. We know how to navigate around it. We know its surface properties from actually touching it. And we have the samples on Earth, so we know its chemistry. And we know maybe how to defend it, so that if the news is bad in 2135, in 2136, scientists and engineers and politicians and the public and managers can make decisions about if and how to divert Bennu or other objects that may pose future threats.
Well, there are two ways to handle Bennu coming to Earth in 2136. Either get a bunch of oil riggers on a space shuttle or have Morgan Freeman as the president.
I think that's already been done, so...
It didn't work out too well, I don't think.
Yeah. Well, one better than the other one.
Exactly. Well, I mentioned last time you were here that for a small sample, we truly have hit pay dirt. So much can be gleaned from just a few grams. We've got the Aussies working on a piece, and you mentioned your time has some research. Your group has some research on the go as well. What other research is happening now on the sample?
So we returned double the amount we needed to. We designed the mission and designed the science that we needed 60 grams to return. We returned 121.6 grams, so double the amount. And that calculation comes from the science team only using up to 25% of the material. The rest of it is archived for the future. And so that, in fact, right now you can write a proposal to NASA Johnson Space Center at curator.jsc.nasa.gov and write a proposal to request a sample. There's also a similar sample at JAXA in Japan, and there will soon be one in the Canadian Space Agency. And so people from now for literally generations to come, there's a sample that's been put in minus 80 degrees C that will not be open for 49 more years, so that people not yet born using techniques not yet invented can answer questions we haven't yet thought of. And so with that in mind, the science team has analyzed our 15 grams, which is half of what we were allowed to analyze, because we want to be judicious in our usage and make sure we leave the maximum available for the future and for other scientists in the present to write proposals. So I had the pleasure of working with one of the largest samples. The organics team took about 6.5 grams of this 121 gram material and crushed it up and made a powder that we then distributed to a dozen different laboratories around the world. The purpose of this is to have as homogeneous as possible of a sample, so we can compare them in the organic laboratories, the isotopic inorganic laboratories, physical properties, element analysis, mineralogy, etc. That was an exciting and stressful event to make sure that you don't ruin so much sample, but it worked out swimmingly. And that sample that we're analyzing now, the results in those papers are being written up and will be published hopefully soon. This paper that came out in January, these pair of papers, only looked at about 80 milligrams of total sample. You can get a lot of information from a little sample. This larger sample is to look deeper and across more different compound classes. And that's work on, as I said, ongoing. We will have them submitted for publication before end of mission in September.
Well, what's it like for you, Jason, watching scientists around the world working on the sample that you and the team are responsible for us having to analyze?
It's wonderful. I've been working for 21 years to get these samples. And so having it come true is fantastic. My job as project scientist is to enable more science than I can possibly do myself. And this sample has gone to labs all around the world. And in fact, it'll be discussed at the Miracle Society this summer in Perth. And maybe you want to go visit and talk to some of the scientists there. It's thrilling to see the sample being used and new discoveries being made. And my hope is that I'll see publications and new discoveries that I can't imagine through my retirement.
That's something...
So it'll be a long process.
Yeah, that's something that I haven't thought of. But of course, with these space missions, it's your life's work because of the time taken to get there, then return the sample. It's decades in the making, as you say. Has the pace picked up now? I feel like we're almost sprinting with all of these new findings coming out. It's only going to get more exciting from here.
There are very few periods of just waiting. There's always something to do. And so even when the spacecraft is just on quiescent cruise, not doing anything, it still phones home once or twice a week to make sure everything's okay. There are weekly reports and monthly reviews to make sure that we are on schedule, on budget, that there are no issues. So it's been constant work the entire time amongst a very large team to get it done. And the pace right now is less frenzied than it was at the asteroid, where in that case every second counted, because we only had so many months at the asteroid, and everything had to be well scripted. Actually, 6 weeks in advance was when the script was starting to be written before an action would happen. So that was an intense phase. Right now, it is intense in a different way because there are many more people far around the world using techniques in their own laboratories. And so the project doesn't have the level of control it has over spacecraft, which I think is wonderful because you get so many more different ways of looking at a thing. It's been spectacular and the achievement of a lifetime. I still have some time to go, though, but move on to the next adventure.
Yeah, absolutely. Well, it is a huge congratulations to you and the team. The fruits of the labour coming through now. Jason, thanks for beaming in to Talking Science once again. Always I really appreciate your time and love it when NASA calls in on the Zoom room. Can't wait for the next discovery.
Pleasure. Good to speak with you as well.
Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week, and the occasional science fiction podcast. Like, follow and subscribe for more. Membership available to help me do more. thetrek.zone/support. This is Trekzone's Talking Science Deep Dive.